Okay, so welcome to our webinar. Thank you, Fatima, for letting me know that the sound is clear. That's brilliant news. Good to have confirmation that all of the technical systems are working well. That's fantastic. Welcome to our webinar today on water sustainability in Qatar, part of Qatar Sustainability Week initiative. And you're hosted here today by myself, Dr. Jenny Lawler from Qatar Environment and Energy Research Institute. And also next, Dr. Peter and Dr. Victor, if you'd like to introduce yourselves.
Sure thing. Thank you, Jenny, for the introduction. I'm Dr. Peter Desmond. I'm an assistant professor in sustainable development with a focus on urban water management at the College of Science and Engineering.
And Dr. Victor.
Yeah, thank you, Jenny. I'm Victor Kochkodan, senior scientist in water center in Kiri. My main field is membrane water treatment and desalination.
That's super, and hopefully we've got an interesting and engaging hour of discussion for all of you coming up as we talk about the very important topic of water sustainability. So for those of you that are joining us from outside of Qatar, let me just take a moment to introduce our institutions to you. So Hamad bin Khalifa University is the flagship university of Qatar Foundation, based here in Doha, Qatar. Arid environment, and we have on board here the College of Science and Engineering, represented by Dr. Peter, and Qatar Environment and Energy Research Institute, represented by myself and Dr. Victor. So to tell you a little bit about our institutions, so Kiri is one of 3 research institutes which are part of Hamad bin Khalifa University, with a focus on environment and energy. And we take a nexus approach to looking at the interplay between energy, water, environment nexus in Qatar, and by extension to other arid regions globally. Our core mission and mandate is to build research and knowledge to inform policy. We look at developing and implementing technologies and methods and solutions to meet environmental challenges and energy challenges for the arid environment. And our key goal is to enhance the resilience in this nexus under a changing climate, so that we can perform research to support arid regions and Qatar going forward. Peter, maybe you'd like to introduce the Division of Sustainable Development at the college?
Yeah, sure thing. So I'm coming from the Division of Sustainable Development. And so we're working across also the water, energy, and food nexus. And so we offer PhD and master programs in sustainable environment and sustainable energy. And so we have, I think, around 6 faculty in all, each representing each area of the water, energy, and food nexus, and similar to Kiri's approach, how they integrate and complement each other. So as a result, that it gives us a way to work in a collaborative way in order to find solutions for sustainable growth within Qatar and the region in arid environments.
Yeah, that's fantastic. And I think it's important to note that we have a very nicely developing research ecosystem here in Qatar. So Hamad bin Khalifa University is just one of the research performing entities here in Qatar. Hamad bin Khalifa University and Kiri were founded in 2011, so quite well developed at this point, and making a good impact on research for the iwi nexus within the country. So the focus today is on Qatar's water sector and sustainability in water for arid countries such as Qatar. So some of you may or may not know that Qatar is classed as an extremely water scarce country. So we have very, very little in the way of freshwater resources available. Although it seems that we have absolutely no scarcity of water at all, that's because we are very well supported by a robust water sector, which is underpinned by desalination technologies. So when you turn on your tap in your house, what is coming out of that tap is desalinated seawater typically. So this is what's called a non-conventional water resource. So for those of you from different countries that are rich in water resources, like myself and Peter, we're from Ireland, we've got a lot of freshwater resources such as streams and lakes, and those are what counts as conventional water resources. So fresh groundwater, surface water. Unlike those other countries that have abundant freshwater resources, Qatar has virtually none. And so we're very, very reliant on desalination to support the water sector here in the country. So you can see on the slide that I'm sharing there, there's a breakdown of what we're looking at in terms of water resources for Qatar at the moment. So we're heavily reliant on desalination of seawater to produce all of the municipal water, the household water, and also for industry. So for construction, for example, we're relying on desalinated seawater. And at the moment, we're producing about 700 million meters cubed per year of desalinated seawater. And we're doing that with about 17 different desalination plants that are located around the country, mainly on the east coast of the country for the municipal water supply. So as well as desalinated seawater, our municipal water sector is made up of a treated sewage effluent network or a treated water network. And we're producing about 250 million meters cubed per year of treated water that's distributed around the country for various different things. And I'll talk a bit more about them later. And also our groundwater in Qatar is almost all what's called brackish. So it's a little bit salty, not as salty as seawater, but about half as salty or less. And that is mainly used for the agricultural sector in Qatar. And again, we are taking about 250 million meters cubed per year of desalinated groundwater out every year. And we also have other non-conventional water resources, which we'll touch on a little bit throughout the course of the webinar. And you can see as well there's something called a water balance for Qatar, which has been done previously by Kahraman. So those of you that are in Qatar will be aware of Kahraman as being the Qatar General Electricity and Water Company, responsible for distribution of water and power throughout the country. And this all comes under the Qatar Water Strategy developed by Kahraman and the Permanent Water Resources Committee. So we have a really good and thriving water and wastewater sector in Qatar. There's been a huge amount of investment into it and a huge amount of thought put into it in terms of management of it as a water sector. So I'll tell you a little bit about desalination, first of all. So as I said, we're surrounded by salty water. It's all around us and it is under our feet in the ground. And we're reliant on desalination technologies. So in speaking to people that live here, often the general public tends to be a little bit suspicious of desalination and you know the quality of water that's produced and whether it's safe or not. So hopefully we'll be able to dispel a few of those myths or assuage a few of those fears today. So in Qatar, there's two major ways that we are desalinating seawater for municipal use, and that's thermal desalination and membrane desalination. So the thermal plants would have been the first desalination plants that would have been established in Qatar and across the GCC. Back as far as the 1950s was when we first had a large-scale desalination plant here in Qatar. And it's a process that has typically been dependent on the electricity production process. So when you burn gas in a gas turbine to produce electricity, you also produce heat from the burning of the gas. And that heat is used in thermal desalination to essentially purify the water. So similar to when you use heat to boil a pot of water or to boil a kettle, the steam comes off that, and that steam doesn't have any salt in it. So that's then condensed, so goes back from a vapor into a liquid form, and it is pretty much salt-free. And that's a thermal desalination process. So because we have a lot of electricity generation using gas turbines, it's very efficient. We're basically using the waste heat from the electricity generation process to generate the water, the desalinated or distilled seawater at the same time. So this has worked incredibly well all across the GCC for more than 50 years. However, when you look at starting to transition, for example, towards renewable energy and you want to work on electricity rather than heat, for example, that you know really carves out a niche for membrane-based desalination. So you may or may not have heard of something called seawater reverse osmosis. So membranes are essentially a physical barrier that will not allow salt to pass through. So it's not something that has holes in it that are smaller than the size of the salt, for example. It works on a slightly different premise than that, typically a solution diffusion type of system, where the salt molecules can't pass across the barrier, but the water molecules can't. And this is what the country is moving more and more towards. So we have quite a lot of membrane-based desalination systems here already. So when you want to desalinate seawater, regardless of the way you desalinate it, either thermal or membrane, you need to look at a few different things. So first of all is the seawater intake. So you need to have a pipeline that brings seawater in, and you have to make sure that that is an environmentally sustainable method. So you want to make sure that you're not going to suck fish and other marine animals into your seawater desalination plant. So that has to be carefully designed. We also have some issues you'll probably have seen if you live close to the coast, like most of us do here in Qatar. You'll have noticed that you do get corrosion on your car, for example, because it's continuously in a salty, wet kind of environment. This is a bad environment for the built infrastructure. So we have to try and avoid corrosion, and we have to try and avoid scaling. So for that reason, when you bring seawater in to desalinate it, you have to do quite a bit of pre-treatment on that. So you have to add some chemicals for anti-scaling and anti-fouling. There's a lot of living things in seawater, so algae, other microbes, so biological fouling can be an issue as well in desalination processes. So we add quite a bit of chemicals, we do some pre-treatments like screening and ultrafiltration, and then you have the desalination process itself, and that separates the seawater into a very concentrated, high salt, high chemical stream, which we call the brine, and then your desalinated water stream, which is now free or virtually free from salt and other impurities. The desalinated stream, the one that we've now purified, that actually has to be remineralized before it can be distributed around to households. So it has to go through a type of filter based on limestone that adds some of the minerals back into the water that give it a pleasant taste and makes it less corrosive and suitable for the distribution systems. And the brine, meanwhile, is typically discharged back into the marine environment. So as you can imagine, because it's high salt, if it's thermal, it can be high temperature, it's got a lot of chemicals in it, and this can potentially be problematic for the environment. So it's something that has to be managed very carefully, and we have environmental regulations that govern the discharge of brine back into the environment. So just a little plug for where research can come in. Kiri Research and Desalination Brine Management is quite advanced. We have a pilot plant in Rasbu Fontas, one of the wastewater treatment plants, and other desalination plants around the place, where we're looking at improving the energy efficiency, decarbonising the sector, and hopefully to minimise the impact of brine on the marine environment. So then the other side of the coin is you've received this desalinated seawater to your house. Now it's high quality, it's fresh. You can use it for cooking, you can use it for drinking, for all of your household needs. And we also use it in industry for cooling, for construction, for car washing, for everything like that. The other side of the coin is the wastewater. So we have extensive wastewater collection networks managed by Ashghal, the Public Works Authority. And we have very high class wastewater treatment plants in Qatar. And that treated wastewater, which comprises municipal wastewater, industrial wastewater, even shallow pumped groundwater, is mandated under Qatar National Development Strategy. It's mandated for 100% reuse. So Qatar is very advanced in that regard, and it's extensively reused in district cooling. So if you live at the Pearl or Lusail or other areas that have district cooling, it's almost 100% reuse water that's in the cooling systems. And we also reuse it extensively in irrigation of landscaping, and also in the growth of fodder in the country, and then also in other non-drinking water or non-potable needs, such as in construction. And just another little plug there, Kiri has a pilot plant in Doe North Wastewater Treatment Plant, which looks at final polishing and improving the quality of that type of water. So I'm just going to stop sharing slides there now, and we'll have a bit of a chat about what I've shared there. So that was a bit of a whistle stop kind of discussion about the water sector in Qatar, mainly desalinated seawater and treated wastewater. So we'll have a look through the questions from the audience. But let's just go to you, Peter, if you want to give us a few of your thoughts on desalination and environmental impact, for example.
Yeah.
While I have the questions from the audience.
Sure thing. So I think you raise a number of really interesting points, and so certainly with desalination and the dependency of desalination as an alternative water resource. If we wanted to be controversial, which sometimes I think we do, you know, in the Gulf, should we really be considering seawater an alternative water source? I wonder, or what meets the definition of an alternative water source within a regional context? That'd be my question to you, Jenny, from your opening remarks.
So what should we consider instead of seawater?
Well, no, so it's the definition of seawater as an alternative water source when it is actually the most abundant resource that we have in the Gulf region. So is it a question to have greater kind of regional specificity in our urban water management plan to reconsider seawater actually as a conventional water resource for treatment and use, given desalination technology has really now reached a strong level of maturation and economic efficiency?
Yeah, I mean, I think it's fair to say that for potable drinking water quality, you always need a good level of treatment. You need a lot of treatment. So actually, regardless of whether you take water from a river or a lake or from the sea, you have to put a lot of treatment processes in place. And you have to chlorinate it or in some way, you know, add chemicals to it to protect the distribution system. So I mean, the global definition is if it's not freshwater originally, it's non-conventional.
Yeah,
So, you know,
because
yeah, it's an interesting point. Like it is the main water source for Qatar and for increasing number of countries, including Mediterranean countries, even, you know, Spain, things like that.
because as a comparison, so when we think so ongoing at the same time as this webinar and within the context of this webinar is the national dialogue on climate change, and so there the thematic area is German-Qatar relations. And so in Germany, as an example, the River Rhine is a key water source. And in certain sections of the River Rhine, despite it being a freshwater source and a conventional water source, we need 7 to 8 unit operations to make that drinkable. And so by comparison, in Qatar, for seawater reverse osmosis, we can actually treat the seawater in 2 or 3 stages in terms of process efficiency. And so I think it's quite an interesting, you know, point of considering these days what we mean today by alternative water resources based on the level of pollution that they carry.
Yeah, very true. Peter, I might just, and Victor, I might just go to, we've got a few questions from the audience here. So somebody has asked, how is groundwater desalinated different from seawater? So I can answer that. So typically, groundwater will be less salty. So what that means is it requires less energy to take the salt out typically. So with a seawater desalination system, we can typically recover about 40 to 50% of the water. So when we take in, let's say, 100 litres of seawater, we can recover about 40 or 50 litres of that as freshwater, and the rest gets discarded as brine. But because the groundwater is less salty and less contaminated, we can recover up to 80 to 90% of it with a typical reverse osmosis system, and with less energy. So a lower pressure is required to treat that. So I'd say that's one way that that groundwater is different from seawater in terms of desalination. But you'll also have some different contaminants between groundwater and seawater. So they'll have a different chemical makeup apart from the saltiness. So that's something that has to be considered. But typically, once we put a desalination process in place, then what you'll see is that you'll have similar quality water as the end product, I would say. I don't know if Peter or Victor, if you want to add anything to that.
Yeah, I think that summarizes it quite well. Yeah.
Okay, perfect. We have another question there. How much more expensive for Qatar to use RO instead of thermal if it decided to reduce CO2 emissions? Anybody want to field that one?
Yeah, I can. So I think in Qatar, I think over 60% of the water is treated now by seawater reverse osmosis. And so it's a question of where the energy comes from, and then also what the associated emission is. So I think there is perhaps a knowledge gap at the moment of a direct comparison in the regional context in Qatar between the CO2 emission that would come from CO2 from a thermal process, which is, it's co-energy and also co-water production. So there could be a benefit there, of course, in terms of the material input into the process without having to generate direct electricity. Which of course is what is needed to run a seawater reverse osmosis plant. So of course that's one of the key reasons why the region was so successful, in the last 20 and 30 years, having co-generation of both energy and then the byproduct of that, of the heat, that could be used quite sustainably actually for desalination and water production. And so for the last 30 years, we could see the original resource recovery for capturing the byproduct of the heat for water, I think could be a good success story. When it comes to the development of reverse osmosis, there's still questions there in terms of where the suitable energy for that should come from. And I see that then as a question from the audience of whether we can have renewable energy instead of natural gas to run our desalination plants. And so I think this is a great question. And there are movements and pilot scale demonstrations of solar as a potential alternative to run desalination plants. But if you ask a researcher, more work is needed. But there are demonstration cases, and maybe Jenny, you have a great insight into that, I think.
Yeah, I mean, if you say, can we use renewable energy as the only energy resource to run a desalination plant, there's a lot of work to be done. But if you just look at where we are in Qatar now, we've got the 800 megawatt Al Kharsa solar power plant that's feeding directly into the grid. We've got another 2 gigawatt plant planned. Like a seawater RO plant doesn't care where the electricity has come from or how it's been made, as long as it's being provided with electricity. So the short answer is yes, we can definitely use renewable energy in the form of electricity from any source to run a desalination plant. Absolutely no issue. And Qatar is definitely transitioning towards that. And then there are other things to look at. So for example, if you look at renewable energy, like you've got hydropower, you've got geothermal, you've got wind power, you've got solar PV, you've got concentrating solar power. These are all different types of renewable energy that will provide energy or electricity in some form towards a desalination plant. If you look at concentrating solar power, that will provide heat as well as electricity. So this is something that, as you said, Peter, there's been quite a few successful demonstration pilots around the region. There's been quite a few in Egypt, for example, and also in Saudi. So this is something that when you look at the system as a standalone being powered by renewables, we're still at quite an early stage. But when you look at just seawater RO, it can run any kind of electricity. We've got a few more questions. So just to keep it easier for us, if you're asking questions, it'll be easier for us if you ask them all in the same place. So if you ask them in the Q&A rather than the chat, that'll be easier. So just going forward, but we can see them anyway. We'll manage. So some more questions from the audience. So are we employing any development of technologies related to recovering backwash effluents from UF and MMF filtration, which I presume is mixed media filtration? If not, is there any space for this kind of R&D? So recovering backwash effluents from UF and MMF, and I'm going to presume that the question is in the context of pre-treatment for desal. Hopefully it is. From our side, we're not really working in that space at the moment, in terms of backwash, because it's not being implemented massively, I think, in the installations that we're working in, but open to comment and discussion on that. Another one from Khawarneem, are there any brine management practices in Qatar? So briefly, kind of, these are amazing, amazing questions. I have to say, there's obviously a lot of knowledgeable people in the audience, which is fantastic. So what kind of brine management practices are happening in Qatar? So the Ministry of Environment and Climate Change would have a vision going into the future of establishing marine protective areas around Qatar, which will necessitate advanced brine management initiatives. So at present, brine is disposed to the marine environment. There are some regulations on it in terms of temperature and chemicals and where it can be discharged. But the research roadmap to the future is looking at brine as a resource and being able to recover valuable things from brine. I'll just go to a couple more questions, and hopefully we can come back to them at the end, maybe, because we did promise to talk about conservation and, you know, what we can do from a personal level to manage our water resources. So I'll just have a look at a couple more questions. Is all underground water in Qatar salty? Yes, pretty much. Yeah, there are virtually no wells that now have very fresh water. How do you ensure storage of slightly salty one you generate does not mix with the non-salty natural one? Yeah, there's virtually no fresh non-salty resources. Another question, for the water consumption and specifically, is there any carbon emission factor as per the Qatari standard? I don't have an answer to that off the top of my head, I'm afraid. Some plants can adapt to salty water. Is there research to adapt other plants to salt water? There isn't within HBKU in terms of like genetic adaptation of plants that can become halo tolerant, but there are a lot of halo tolerant plants out there. And there's a lot of global research on the use of halo tolerant plants, not only mangroves, for greening. So yeah, that's something that we can do. All right, we'll move on to the next section of the presentation. So I think that is Peter. So if you want to share your screen. So we're going to talk a little bit about water conservation measures and some innovations in terms of water conservation. And hopefully we'll get the chance to get back to any questions we haven't managed to answer. Hopefully we'll manage to get back to them towards the end.
Great. So you're able to see my screen? I think I have the first slide. Yeah.
Yeah, it's perfect. Thanks, Peter.
Right. So thank you very much, Jenny, for your introduction. And so I think I'll continue where you left off in terms of the reference to desalination as a principal source of potable water, and certainly within the residential space. So what we see here is an overview of what water sources are used in Qatar. And so we see kind of mixed use of, in the blue here, potable water. So this is coming, of course, from the desalination plants. We also see a mixed use of groundwater still in some regions within Qatar, but as I understand now, this has been phased out. And we have extensive use then of TSE, largely for non-potable applications. And as Jenny mentioned, this is used now quite effectively for district cooling, also for irrigation, and some other kind of non-edible agriculture, so for potential use in fodder. But one of the challenges that still exists is the extensive use of potable water for perhaps non-potable application within residential, so in terms of apartments or offices or within villas. And so the question is, what can we do, you know, ourselves as individuals to lower our water footprint, but, you know, combining with some new innovations in the area of urban water management. And so again, in reference to what Dr. Jenny was talking about, was through water conservation, through water reuse. So Ashghal has quite an extensive network. We see here, you know, the city of Doha, and that allows us to collect our wastewater, but not discharge it into the environment. But we can have extensive treatment, and certainly what's been done in Qatar, reuse of the wastewater. So we see mechanical treatment, biological treatment to remove some nutrients or organics, and then an extensive post-treatment to bring the water quality up to a suitable level to allow it to be reused. And so this is typically where the TSE is coming from, and how it can be distributed then in its dedicated network for purposes of irrigation or also cooling. And so this is what we would call an example of centralized water reuse. And I think Qatar certainly is doing a really incredible job in the implementation of centralized water reuse through the operation of dedicated water reuse facilities, but also dedicated water distribution networks. And so having a potable distribution line and also a treated sewage or water recycled distribution network as well, running in parallel as a fully segregated system. And Qatar is also doing a very good job in the concept also termed decentralized water reuse. And so we look here at water reuse not in a city level, but we see here on the left, actually but on the right within an individual unit within the built environment. So this could be an office building, this could be your own villa, it could be your own home. And there's many ways in which we can have the aspects of decentralized water reuse. And so what we see here is collection and separation of different types of water. So we see gray water being collected from hand washing or shower areas, separated from black water, which is coming from the toilets. And then within buildings of truly sustainable developments. And so we'll see an example of what we mean by that in the next slide. We're able to collect these different water streams with different degrees of pollution and then treat them for a different application. And so we see here collection of gray water. So from hand washing, ultimately we are able to use this for irrigation. We have an example of this in Education City, or we have the possibility to reuse the black water also for non-potable application. When we think of an example of decentralized water reuse, Qatar again is leading the way here. We see the development of Masharab downtown, which has reported to have source separation of gray water from black water, which again reduces the dependency on potable application. In the case here for toilet flushing. So as I understand from publicly available information, toilet flush water in Masharab downtown, it uses TSE, and this is facilitated ultimately by source separation. Also within Education City, we have source separation of the grey water from the black water, and this is serving as an ideal test bed or living laboratory in order to see the use of grey water, treated grey water for potential irrigation of blue-green infrastructure. And when we look inside our own homes, we see ultimately potential for recovery, not just of water, but also some nutrients. And so we see it is also possible to have a separation between solid and liquid waste streams within the bathroom. And so we see here this possibility to recover urine, to recover nitrogen, phosphorus, and potassium, which we'll see actually makes for an ideal fertilizer. We have the possibility for black water treatment, so largely solids or organic material that contain a source of energy or nutrients that can also be reused. And again, the highlighted area in the former slide, we're talking about grey water treatment. So this is referring to domestic water sources from kitchens, bathrooms, laundry rooms, which can be treated and reused again around the household. And so there's multiple examples in the world and also in Qatar where grey water is a subject of extensive research. And so not only research, but also being implemented into the real world as a way to reduce the dependency of potable water for non-potable applications that could be used for toilet flushing as an example, or irrigation. And so what could a property owner do in order to implement some of these technologies? And so on the left-hand side, we see actually a very nice product that was developed by the Swiss toilet manufacturer, believe it or not, Laufen. And ultimately, this is a source separation toilet. So it's all well and good that we have these academic concepts, but ultimately we need to be able to get these technologies and these concepts into the market and into the hands of the consumer. so they can really, implement their own sustainable development strategy, whether, it's at work or also importantly in their own lives. And so that's what we see here. And one of the highlights that we'll feature as a way to, maybe consider if you're building your own home or you're creating your own residence within the premise level, what you could do in order to reduce your water footprint on a technological level. And so the product here from Outcome, we see the source separating toilet. So we actually are able to separate the urine through a novel construction here, or as through a urine trap. And we see also then separation then of solids. And so we have a separation of a solid and a liquid stream. This source separation is a key facilitator in order to be able to recover different nutrients and also then reduce burden on a potable water supply. And so this is an example of the toilet that was implemented at ELVAG, so it's the Swiss Federal Institute for Aquatic Research and Technology. And we see here then the different collection points for the various waste streams that are integrated within a municipal building and that have also now been implemented in Switzerland in residential buildings as well. So that gives you as an example. And so another example to highlight of your potential starting point on becoming water wise could be engagement with many fantastic initiatives in Qatar. So with Tarashid, as I see, they have available, a water and energy consumption calculator on their website. And so when you were thinking within your own residence, what your energy or what your water usage is in a specific room or within the garden, they even give you the option, or in your backyard, to calculate water or energy demand based on what utilities you have installed. It's a really fantastic tool from Kadama and from the state of Qatar in order to, as they say here, keep Qatar pulsing, and so you can consume wisely. And the key message here is to consume your water wisely. So thank you very much.
That's awesome, Peter. I learned a lot there. Very, very cool innovations. We've got some, but yeah, definitely we could have some more innovative things in our households. So hopefully we'll maybe hear something from the audience in terms of what they have been doing in their households in terms of being water wise, as you say. I'll just bring a couple questions in from the audience, if that's okay. We've been asked, when we use treated but non-potable water for agriculture, some vegetables absorb and store a lot of this water. Is it still safe to eat them? So I can tell you that in Qatar, we're not using treated water to grow any edible food crops, only for fodder crops, but it is done extensively in other countries. And we import foods from those countries, so they are widely available on our supermarket shelves. So is it safe to eat them? So any country that's using treated water for growing of crops will have a set of regulations that govern the quality of that water. So typically the water quality will be high, and typically, yes, it should be safe to eat them. And any of the imported foods that we are eating here, they are undergoing, quality control, both at the port of origin and also when they come into Qatar. So I would say the short answer is yes, it is typically still safe to eat them. We had another question there about edible salt. Why does Qatar not produce its own edible salt from brine? So I'll field that one. So yes, edible salt, there's a huge market for edible salt, but it has to be safe for human consumption. And the brine that we're producing from desalination plants is typically, it's got quite a lot of chemicals in it that would have to be cleaned up before we could use it as an edible food product. And that would cost quite a lot of money to make sure that it was pure and it had high quality standards and it wasn't contaminated in any way. So that's why we're not producing edible salt. Edible salt is not a high value product. It's a commodity product. It's got a very low selling price, and the amount of investment that would be required to clean up the salt would be very high. So it wouldn't be economically favorable to do that. However, we do have a new salt plant here in Qatar for industrial purposes down in Mesaid. So that's something that's very exciting. So potentially a very high value use for the brine for industrial purposes. Okay, I think Victor is going to tell us a little bit more about what we can do in terms of conservation. So Victor, if you want to share some informative sides.
Yes, thank you, Jenny.
Going to go into
So
slideshow. Perfect.
So let's go to the final topic of our panel today. We will talk about what everybody can do at your home to reduce water consumption. But first of all, we need to identify where we have these water saving opportunities. And if you look at the diagram here, you can see here that 27% we consume water in shower, 50% for toilet flushing, bathroom tap, 12%, kitchen, laundry, 50%. So the main areas of high water consumption at home, bathrooms, usually toilets use about 6 to 13 liters per flush. Showers typically consume about 10 liters per minute. Kitchen, hand washing dishes can use about 30-40 liters per session, and dishwashers usually take about 40-55 liters per cycle. And laundry, for typical traditional washing machine, they can spend about 100-170 liters per load. And for outdoor water usage, especially in Qatar, it can account for more than 50% of household water usage in this climate. So that's why Qatar's per capita water consumption is one of the highest in the world, and in average it's about 500 liters per person per day. And just simple change in your daily routine can lead to sustainable water saving. So what we can do, for example, for water conservation in bathroom? The key tips, it's fix leaky toilets. Leaky toilets can consume a lot of water, and water waste can be between 700 and 1,000 liters per day, depends on how severe is the leak. So another tip, instead of bath, usually it's take about 200 liters of water to take a bath, take showers, but not only take showers, but try to reduce time for showers. For example, if you take shower for 10 minutes, you can consume about 90 liters of water. If you take shorter showers, for example, for 5 minutes, you can save about 45 liters of water. And for family of 4, for 1 year, you can save about 35,000 liters of water. And of course, very simple, but very important tip, just don't leave the tap running while brushing your teeth, because you will consume about 15 liters of water while you need only 1 glass, about 200 milliliters of water to brush your teeth. So this is a very important tip. And again, for family of 4, by using this tip, you can save about 11,000 liters of water. Water conservation in the kitchen, laundry, and outdoors. So for kitchen, the simple tip, don't let water run while washing dishes by hand. So just fill your sink with water and wash your dishes. Don't run water. Instead of running water while washing or peeling fruits and vegetables, use a large bowl, and in this case, you can save a lot of water. When cooking, use only the amount of water required. Don't use a lot of water. And run this water only with full loads. This will help you save some water in your laundry. For outdoor, because we live in a hot climate, use drought-tolerant plants because they require less water. and try to water your gardens early in the morning to reduce evaporation. In this case, you can save about 20–30% of water. If you can, just try to install drop irrigation. It can save about 50% of water, and you will use only 30 liters per hour compared to traditional sprinkler system, which are highly water consumed, about 100 liters per hour. And rainwater collection. So we don't have very often rains here in Qatar, but sometimes rain quite heavily, and we can collect a lot of water. Try to collect, to set up some barrels to collect this rainwater and use it for irrigation and in your gardens. But reducing water consumption at home is not just individual responsibility. Very important to be involved in some community actions. And here in Qatar, Qatar General Electricity and Water Corporation, Kahramaa, they have very interesting and important programs and initiatives. Peter mentioned about Tarshid campaign. The aim of this campaign to educate Qatari people on conservation and efficient use of water and electricity. And this program was launched in 2012, and up to date, it helped to save more than 1.8 billion cubic meter of water in Qatar. In Doha, in Qatar, Kahramaa, they established awareness park in 2017 to educate the public about water consumption, to show the latest technologies in water treatment. And if you visit this park, you will be amazing. It's very interesting and very fun activities you can have there. And also, Kahramaa provides very useful resources and tools, water saving tips, water saving devices. When you install these devices at your home, you can have about 20–40% of water saving it at your home. And try to lead by example. Share your water saving practices with friends, family, and neighbors, and they will motivate others to adopt similar practices. Advocate for policy changes. Engage with local policymakers to support regulation and to promote water conservation. And for example, here in Qatar in 2015, it was issued an act that prohibit using of potable water for car washing. And this act was issued because public raised concern about this issue. So there are some very good examples how your active actions can be beneficial for water saving. And also use social media like Twitter, any social media, Instagram, Facebook, to spread the message about your water conservation practices. Share tips, success stories, and local initiative to inspire others to take actions.
I think that's a really interesting point. We can all be kind of a champion for water conservation, can't we? I think I'll just go to some of the comments and questions from the audience. It goes nicely with your conclusions slide, Victor, for sure. So one of our attendees asked about involving the community to become a wise user for sustainability. I think that matches really well with what you said. The Tarshid campaign has been amazing in terms of involving the community. And then, of course, you know, we have initiatives from entities such as ourselves to host events like this, and Qatar Sustainability Week, I think, is a very important part of the picture there. We've got a few more questions from the audience there. So somebody asked, why has membrane distillation not got a greater application in desalination and public acceptance? I mean, that's a really interesting question. I mean, the short answer is that it hasn't been scalable. So it's still very, very relevant in terms of niche applications, but for large scale desalination systems, it hasn't proven to be scalable. And a lot of companies have come into the market and tried and failed to get large scale systems underway. Another one of our attendees asked about the capture of water from air, and will that ever be a credible alternative to normal desalination systems? We could have an entire hour talking about that, I think, as a topic. So there are water from air systems out there, but again, the production amount is so small that it won't meet the potable water needs for sure. So it can have a niche application. And there's been, particularly in Qatar, a big focus on capture of humidity from air to provide for agricultural needs. So Qatar Research Development and Innovation Council, along with Hassad Foods, launched a call for that as a research initiative a couple of years ago. Like, there's a lot of very promising units that are coming towards commercialization with quite large volumes, so up to more than 10,000 litres per day. But again, the amount of water requirements that we have proven that it's not quite possible yet. And particularly when you look at the energy requirements for those types of systems, you know, definitely applications for off-grid systems and modular systems, but for a main municipal water supply, not yet, unfortunately. And just another couple of questions we were asked is rainwater collected in Qatar? And we were also asked about water coming from AC systems. Is it collected also? So rain is an interesting one. So yes, you're correct that we have sporadic rainfall in Qatar. But Kahramaa have put significant investment into rainwater collection wells, which are dotted around the country. I think we have more than 100 rainwater collection wells installed by Kahramaa around the country. And the idea of them is that they will feed rainwater back into the aquifers. And another thing as well is around Doha, obviously we have, you know, when we get rainfall in the city, that has to be managed in terms of floodwater and stormwater management. And that water is actually collected as shallow underground water, and it goes to our wastewater treatment plants as well. And it's dealt with in the same way that our treated sewage effluent, and it comes into the distribution system from that. So Qatar has put a lot of investment into that in terms of rain and stormwater management in the last few years. And then AC systems. So obviously somebody in the audience knows a little bit about what they're talking about here. We do harvest a lot of water from AC systems, particularly from the air handling units in larger buildings and commercial buildings. That water is collected, but it is currently sent to the sewer. But Kiri does have a research program to look at AC systems and the recovery of water from AC systems. So a question that I love. So I think that's probably all that we have time for today. So I'd like to just get a few kind of closing remarks from my co-panelists. So Victor, Peter, if you'd like to just give a few closing remarks and summary of what we've talked about today.
Sure. So thank you, Jenny, for hosting this really great session. So I think my closing remark will be one of positivity. You know, I think Qatar has certainly done a really fantastic job in developing sustainability in urban water management. And so that's evidenced by the extensive water reuse within the country and the development of very reliable. So we have projects with the desalination plant companies here. So we know firsthand very reliable and robust and resilient desalination technologies. And so I think Qatar is certainly leading, you know, the world in circular water management. And I think it is a fantastic test bed, you know, for people to come and see, you know, what a truly modern urban water management strategy looks like in practice.
Thank you, Jenny. I wanted to say that water is very valuable resource, and we need to do our best to save and to protect this valuable product. And please remember, it was mentioned in one of the slides that for 30 man, drop of water is more valuable than sack of gold.
Yeah, I have to agree with you. And I think if you look at you know, particularly this region, if we compare the valuableness of oil versus the valuableness of water going forward, I think we know which one is going to win out in the end. So thank you very much to my panelists. Thanks to all of you for attending. I think it's been a fantastic session. Really, really great questions from the audience. We've had a question, can we get the recording? I think that the recording will be made available on our LinkedIn channel following the webinar. And you'll be able to contact us, any of us, via Kiri's LinkedIn channel as well. No issues at all. We'd always be delighted to hear from you. So thank you very much again. Thanks for joining us. Thanks to the panelists. Thanks to Kiri and the HBKU College of Science and Engineering. And we'll leave it there. Enjoy the rest of your day. Take care.
Thank you.